So we're finishing up section 5 today. So we're still doing some operations with radicals, so we're simplifying these expressions. So you can use the product and quotient properties to multiply and divide radicals. So we're still using those two properties we talked about yesterday to simplify our radicals here. But now we can multiply them together. Okay? So in example 1, we want to multiply these two terms together. Yeah. So if I have numbers on the outside, I can multiply those two numbers together. So if I have 6 times 4,
24.
That is 24. Now underneath your radical or square root here, you can also multiply all of those terms together. Okay? So if I still have this square root, I'll have 8 times 2. That's 16. I have c to the third times c.
C4. That's like the explosives.
And d to the fifth times d cubed.
D8.
From here, I can kind of do what we did yesterday, so we're going to simplify. So can I take the square root of 16?
Yes.
All right, so I still have 24 on the outside. Now these are multiplied together. So square root of 16 is 4. So times 4.
Oh, you don't put the radical?
Nope. Can I take the square root of c to the fourth?
Yeah.
Yes. So take your exponent. Take your exponent, divide by your number or your index. So I have 2 pairs. Yep. And then d to the 8th.
D to the 4.
D to the 4th.
Yeah.
Okay, last step, I can multiply 24 and 4 together. That's 96. C squared, d to the 4th.
That's it?
That is your simplified answer.
That's pretty easy.
All right, we're going to do another one.
Yeah.
So letter B, there's too much talking. Letter B, again, I can multiply the numbers on the outside. So 2 times 3 is 6.
Oh, that's under radical.
I still have this radical. It is a 4th root, so don't forget that 4th root symbol there. Now I can multiply what's inside that radical together. So I have 8 times 2 is 16. X cubed times x to the 5th is x to the 8th. Y squared times y squared is y to the 4th. Okay, now I want to simplify. The 4th root of 16 is 2. Okay, so I took the 4th root of 16, that's 2. The 4th root of x to the 8th, I'll take that 8 and divide by 4. And then I have y to the 4th. It'll be y. That y needs to be in absolute value symbols because it's odd. So I had an even power, an even root. I ended with an odd power. Okay, now I can multiply together 6 and 2. That's 12. I have x squared and the absolute value of y. Okay, not so bad. All right, so that's multiplication. Shh, we're quiet, please. We need to focus and pay attention. That is multiplication. Now, radicals can be added and subtracted in the same manner as monomials. Okay? in order to add or subtract, the radicals must be like terms. Okay, just like when you add x squared plus x squared to get 2x squared. Those are like terms, so you can add them together. Same thing with your radicals. They have to be like terms to add or subtract. Now, radicals are like radical expressions if both the index and the radicand are identical. Okay, so here I could combine these. It's the square root of 3b and 4 times the square root of 3b. Okay, so your radicand inside is the same, and the index on the outside is the same. Now, unlike radical expressions, if I have the square root of 3b and the cubed root of 3b, those are different. Okay, I cannot combine those two because your index is different on that outside. Okay, just like you can't combine x squared plus x cubed. Okay, those are different terms. They're not alike. And then same here. If I have the square root of 2b and the square root of 3b, underneath your radical symbol, so the radicand, that is a different number, so you cannot combine them. Just like if you had y squared and x squared, you can't combine those two. Okay? So we want to simplify our expressions here. So in letter A, we have 4 times the square root of 8 plus 3 times the square root of 50. So I want to simplify what's underneath that square root first. So I want to look for two numbers that multiply to get to 8 where one of them is a perfect square.
2 and 4.
2 and 4. Okay, so to get to 8, I can multiply together 2 and 4. What about 50?
25.
25
25.
and 2, right?
Yes.
So I'm going to rewrite this. I'll have 4 times the square root of 4 times 2 plus 3 times the square root of 25 times 2. Okay, so here again I'm just simplifying. I can take the square root of 4, that's 2. So I'm taking out a 2. Now there is a square root of 2 left there, so that stays underneath your radical. Plus 3, square root of 25 is 5. So multiply by 5. And then again, I still have this left over 2, so that stays underneath that radical symbol.
Okay.
So I have 4 times 2 is 8 times the square root of 2 plus 3 times 5 is 15 times the square root of 2. Are those two radicals like terms?
Yes.
Yes, so I can combine them. Okay, both of them are the square root of 2. So I can add together that number on the outside. Okay? So I'll get 23 and keep that square root of 2. Questions? All right, so looking at letter B then, same process. I want to simplify each of these radicals here. So I want to find two numbers that multiply to 12 where one of them is a perfect square. That would be 4 and 3.
4 and 3.
All right, next I have 27.
Oh, 9 and 3. Oh, sorry, someone's beating the
The last one I have here is 128.
A big number and a small one.
64 and 2.
Yeah, told you.
All right, so next I'm going to rewrite this. So I'll have 5 times the square root of 4 times 3. because that's still 12,
Yeah.
plus 2 times the square root of 9 times 3. Again, that's still
Minus.
27. Minus the square root of 64 times 2. All right, so I still have 5 on the outside. The square root of 4 is 2, so I can multiply 5 by 2. What's left underneath that radical is the square root of 3 plus 2 times the square root of 9 is 3. Then again, I have a square root of 3 left after I take that. Then minus the square root of 64 is 8. And I'm left with that 2 underneath that radical. Okay, I can simplify here. So I have 5 times 2 is 10 times the square root of 3 plus 2 times 3 is 6 times the square root of 3. And then I still have minus 8 times the square root of 2. Yes, so I can combine these two. Good. Okay, both of them are square root of 3. So I can add together 10 and 6 to get 16 square roots of 3. And then I'm going to leave that minus 8 times the square root of 2. Okay? And that would be your simplified answer, because you can't combine those. Questions on simplifying? Okay, then on the bottom. Shh. We're quiet, please. On the bottom, we have 2 that are multiplied together. Okay? 2 expressions multiplied together. Now they do have this subtraction and addition within there. Okay? That means that you need to FOIL this. Okay? So we're going to FOIL.
Foil, F-O-I-L, foil.
So we're going to multiply our first terms together.
Yes.
So we have 6 times 2.
It's like 12.
That's 12. Now we have the square root of 3 times the square root of 5.
Square root of 15.
That's the square root of 15. Okay, then our outer terms. So that first one, and that last one. So we have 6 times 4, 24. We have the square root of 3 times the square root of 2.
Square root of 6.
Now our inner terms here, we have this negative 5 times 2
Negative 10.
is negative 10. And then we still have that square root of 5.
Minus 20.
Then our last terms, we have negative 5 times 4. So minus 20. And then the square root of 2. Can I combine any of these terms?
No.
No. You can't simplify any of those terms any further either. So that's your answer.
Chicken dinner. Why wouldn't you just leave it like that short?
It's just so you understand the process.
You don't understand it.
Because on the back, you're going to have to do that process and it'll be shorter.
So we need to understand something that we're not going to use
No, you're going to use this.
in life.
Yep, every day. All right. Quiet, please. Quiet.
I answered your question.
Thank you. I'm glad.
Yeah.
We're going to do letter B now. So again, we're foiling these terms out. So I have 7 times the square root of 2 times 7 times the square root of 2.
Can you just combine them?
So 7 times 7 is 49. Square root of 2 times square root of 2 is square root of 2, which is what? 2. No? Did I lose you?
Did you just take it out right away?
Yeah.
You just did it right away.
Okay.
Square root of 2 times square root of 2. If you have the same square root times that same square root, it's just going to be the radicand in the middle. So it's 2. I won't do that for the last one if it makes you feel better. Okay, outer terms. Huh? Yeah. Outer terms, we have 7 times 3. 21. Shh, quiet. Square root of 2 times square root of 3 is the square root of 6. Inner terms, we have negative 3 times 7, so minus 21. Square root of 3 times square root of 2 is square root of 6. Last terms, go sit down. Last terms, we have the square root of 3. Shh. You guys need to pay attention. This is why you guys don't get any time to work on your homework. No, you're just talking in the middle when you could be paying attention. We're on the last terms here, so we have negative 3 times 3.
Negative 9.
I have square root of 3 times the square root of 3 is the square root of 9.
You can't do 3 now?
You can, but you guys got all confused when I did that last time.
Well, if you did it once in the problem.
Well, now I'm going to not do it.
It's impact.
It's like you're cheating. You're making up rules as you go.
I'm not. I just simplified faster on this one. So, simplifying here. We have 49 times 2.
98.
Can I combine these two?
Yes.
Yes, what happens to them? They cancel.
Wow.
Last I have this minus 9. The square root of 9 is 3. So we're taking 98 minus 27. That is 71.
Oh my gosh.
When you get problems like this is actually the conjugate. Okay, you'll notice that these two terms are the same, but the difference is there's a plus and a minus. Okay, your middle terms are always going to cancel out. So you just honestly have to multiply your 2 first and your 2 here last. No. Yeah, it's still like the same process. So binomials form a times the square root of b plus c times the square root of d, and a times the square root of b minus c times the square root of d, where a, b, and c and d are rational numbers called conjugates. Okay, that's what I just kind of explained on the front. Okay, they're conjugates of each other. So you can use these to rationalize the denominator. Okay, remember when I said you can't have those radicals in the denominator and you have to rationalize it? You're going to use conjugates to do that if you have a plus or minus within that denominator. So in example 4, golden rectangles have been used by artists and architects to create beautiful designs. Many golden rectangles appear in the Prythian in Athens, Greece. The ratio of the lengths of the sides of a golden rectangle is 2 over the square root of 5 minus 1. So we want to use the conjugate to rationalize this denominator.
And
simplify. So I'm going to start with 2 over square root of 5 minus 1. I want to multiply the numerator and denominator by the conjugate of the denominator. So I'm going to multiply by the square root of 5 plus 1, conjugate, over square root of 5 plus 1. Okay, so I multiply straight across when I do this. So I'm going to leave this as 2 times the quantity square root of 5 plus 1. Now in the denominator, since this is a conjugate, you just need to multiply your first terms and your last terms. Your middle terms will cancel out. If you still feel like you need to multiply your middle terms because you don't understand that, you can. So I'm just going to do that anyways. Yes. So square root of 5 times square root of 5 is the square root of 25. Okay, that's 5. Square root of 5 times 1, right? Square root of 5. Negative 1 times the square root of 5 minus square root of 5. Negative 1 times 1, negative 1. Now you'll see those two middle terms, they cancel each other out. Okay? So here we'll have 2 times the quantity square root of 5 plus 1 all over 5 minus 1. If you wrote 4 right away, that's fine. So this is equal to 2 times the quantity square root of 5 plus 1 all over 4. Can I reduce that fraction?
Yeah, you can to 1/2.
Oh, and 1 and then 5.
This right here. If I have 2 over 4, that 2 cancels to 1. 4 will go to a 2. So we can have square root of 5 plus 1 over 2.
You're going to mark us wrong on the test if we didn't do that, okay?
On the top? Yeah. Questions on how I rationalize this denominator here? All right. Last example at the bottom. What time is it? So, again, we want to rationalize the denominator. So, we're going to take this problem here. Shh. Quiet. So we have a over a times the square root of 2 minus a. What is my conjugate that I'm multiplying by?
A square root 2 plus a.
Yes. All right, again, I multiply straight across here. I'm going to leave a on the outside and keep the numerator the same as it was. So I have a root 2 plus a. Now since I'm multiplying by the conjugate, again, all you need to do is multiply your first terms and your last terms because your middle terms will cancel. That's why we multiply by the conjugate. So if I have a times a,
Squared.
that's a squared. Square root of 2 times square root of 2. Square root of 4. Yeah. My last terms, I have negative a times a. All right, so from here, just to simplify it a little bit more, what do these two terms in the numerator have in common in those parentheses? A, right? So can I take out an A? So if I take out 1A and I have A times A on the outside, then what is that? A squared. What would be inside those parentheses then if I took out an A? What would that turn to?
You can just do that from the beginning, right?
Yeah. In the denominator, what do both of these terms have in common?
Some A's and some 2's.
A squared, right? So I can take out an A squared. And then I'm left with 2. Minus, if I took out the A squared, I'm left with 1. Now I did this because I know that these will cancel out now because I have A squared over A squared. So I'll have square root of 2 plus 1 over 1, which is just the square root of 2 plus 1. Okay, so multiplying by the conjugate to rationalize your denominator and simplifying those radicals. I want you guys to finish the assignment from yesterday. I'm going to give you today's too. I'm going to give you time tomorrow to work on both if you didn't finish them. This one is not as long. For those of you who aren't going to be here tomorrow because you're going to the FFA thing, we're going to do whiteboard problems and then work on the assignment. So you won't miss any words or anything like that.
Oh my goodness.
So either work on your assignment from yesterday or the one I just handed you, please.